Welcome to another Python GIS tutorial today, guys. So today we're going to be using GDAL to calculate normalized difference vegetation index, or NDVI. In our last video, we downloaded a Landsat 8 image, and we're going to use that same image to calculate the NDVI. So if you don't know how to download Landsat 8 data, or don't have data to calculate NDVI, go ahead and watch that video, and I'll link it in the cards. So what I'm going to do is I'm going to come down and just grab that image that I created, or that I downloaded. And this image, I believe, has 7 bands. So we'll come to the Landsat Data. Make sure I get the right one here, and it should be this top one. So I'll pull that in. Take a minute to load here. And while it's loading, I'm going to go ahead and open my plugin, my Python console plugin right here. Okay, and what we're going to do is we're going to use some functions we developed last time. In the last Python GDAL tutorial. And if you haven't seen that tutorial, I'll link that in the cards above so you can get access to these functions. This is going to streamline things a little bit, because these are things like opening rasters, getting a raster band, creating rasters. Those are things that we do a lot of, and I'm just going to use those functions to streamline this. So I'm going to go ahead and copy these first functions here and create a new script and add those in. Let's go ahead and take a look at our image here real quick. So there's our Landsat image. And we're being a little slow here zooming in. I'm going to enable my value tool so that I can see what values I have. Okay, good deal. So now one thing we need to note, there are 2 things we need to note. I'm going to open that console back up here. The first is we need to be able to note which bands we need for NDVI calculation. And then we need to note what the value ranges of those bands are so we don't include any no data values. So first, let's see what NDVI is. I have it pulled up here on Wikipedia. We have our equation right here, which is the near infrared band minus the red band, and the near infrared band plus the red band. So let's find out what those band numbers will be. For Landsat 8, so I'll just Google Landsat 8 bands. And this will bring us to the USGS website, which has the band designations. And that's Landsat 1 to 5, 7, and here's 8 and 9. So our red is band 4, and our near infrared is band 5. So we're going to need band 5 and band 4 out of this image. Okay, so let's go back over here. And the other thing we're going to need is we're going to need to know what the values of those bands are. And so I'll tell you right now, without going into all the documentation, that the valid values for the Landsat 8 are 0 to 10,000. So anything less than 0 or greater than 10,000 are erroneous values or no data values, so we need to filter those out. Okay, so we have some functions here. We're going to create an NDVI function next so that we can calculate NDVI. So what we need to do is we need to just put in the NIR band, the red band. Oh, I need to put a def NDVI. Okay. And then we're going to have an output band, or our NDVI band is going to equal, we'll put NIR band minus red band. These parentheses are important because we have a division in here. NIR band plus red band. And then we can return NDVI band. Okay, so that'll give us that calculation. Oh, guys, I just noticed an error here. in this get raster band function, we need to change this to bands so that we use that parameter. Okay. All right. So now, what we need to do here is we need to open our raster. We need to get the red band. We need to get the NIR band. We need to calculate the NDVI. Sorry, we need to get those bands. We need to filter out the values that don't contain data, assign them a no data value, calculate the NDVI band, and then write that to a new raster. All right. So we're not going to be able to create a raster from copy in this instance because our input raster has multiple bands and we just want one output band. So what we're going to do is we're going to do a function to create a raster. We'll call it from template. And we'll input a raster data set. And we'll give it a driver format, which in this case we'll just set the default to GeoTIFF. And then we'll use this input data, getting this backwards here, input data source or data set to create a new raster. And we'll get to those details right now actually. So let's do our driver equals GDAL.get driver by name. And then we're going to give it the driver FMT. And then we want to do our outDS. Oh, I forgot one thing here. We need to give it a file name that we're going to write to. So our output data set equals driver.create. We're going to give it our file name. We need to give it our size, our projection, and so on and so forth. I'm just going to double check and make sure I get these in the right order. So hold on for just a sec while I check my notes. Okay, so first of all, we're going to give it the rows, which is going to be the X size, and that's going to equal the input data source, raster X size. Our Y size, number of columns, which is going to equal ds.raster Y size, do a comma, and then we're going to start a new row here. And then we want to give it the bands equals 1. And then we need to give it the data type, which is going to be a GDAL data type. Sorry, GDAL.gdt float 32. Okay, and let me just make sure I get that variable name correct there. And so this is going to be heat type. Okay. So now we have our output data source. We can do outDS. We need to give it a geotransform. So this is going to line it up in space correctly. We're going to do ds.get geotransform. outDS.set projection. ds.get projection. Okay, so that'll give us all the projection information. That'll line that up. And what we can also do here is we can give it the data. So that'll be the raster band. And then we can give it our no data value. I'm just going to set this equal to -9999 for starters. And I'll put a new line in there to make things easier for us. Okay, so I think we're all set here. We have the way to calculate our NDVI band. We have the way to write our output raster. So now let's just go ahead and load up our inputs. So we're going to have my input file name, which is just going to be the path to my raster that I have loaded in QGIS. Temp Landsat, and then I copied the file name to my clipboard because it's kind of a hairy one to remember. I'm going to have my outFN. I'm just going to name this NDVI.TIFF. Okay. And then we'll call this my NDVI data is going to equal the NDVI function, and I'm going to give it a red band. Oh, we need to get the bands first. Let's get our bands first. Let's get our red band. Is going to equal get raster band. We're going to give it our in file name. Our band number is going to be 4 for red. NDVI band is going to be get raster band. Actually, so let's do this a little more streamlined. We can add this into the NDVI function. So we can do, actually no, we'll do it this way. We'll do it this way. Sorry, I got ahead of myself there a little bit. So we'll do get raster band in FN and band number 5. Or sorry, that's NIR band, not NDVI band. Let's name this correctly. And now let's name this NDVI band equals NDVI, and we want to give it NIR band, red band. So make sure we get those correct. And now we can create a raster from a template. And so we can do create raster from template. We can give it our out file name. Then we need an input data source, which is going to be GDAL.open, and we'll open our input file name. And then we need the data, which is going to be our NDVI band. Okay. All right. So that looks pretty good here. Okay, so remember how we need to filter out any values that are less than 0 or greater than 10,000? We need to add that in here. We're going to add that into the NDVI function. And the way we can do that is we'll do NIR band. And if we do NIR band, or sorry, greater, we'll do less than 0. We're going to make that equal to a no data value. So let's input a no data value here, and we'll just make this -999. Actually, sorry. We're going to make this our numpy NAN value. So we need to come up and import numpy as np. And so this will set this to not a number of values that will not be included in these calculations. Okay. We do NIR band greater than 10,000. Also equals np.nan. We can just copy these now. And do the same thing for the red band. So we'll copy red band and replace those here. So now when we do this, we'll get an NDVI band that has np.nans in there. And now we're going to actually put in a no data value. And I'm going to set that default to 9999.0. And we'll do, here we need to just change the NDVI band where it equals np.nan. We just need to change that to -9999.0. Okay. And so the way we do that is we just open our brackets again. We type is NA. We give it NDVI band. Sorry, this is parentheses. NDVI band. Close our brackets. equals NDV. All right, and then we're going to return that NDVI band, and it will have that node data value. Okay, so now when we create our raster, we now need to make sure we write that data. So we need to do outds.get raster band 1 set node data value outds.get raster band 1. I need to write the array or write the data. That's where we're going to put in the data. Okay. And then we can do outds equals none. And that will close that right up. And then we also here will write ds equals none to close that other data set we send in. Okay. Oh, sorry, this needs another parenthesis down here. I'm missing one on the open. Now I think that might cover us. I'm just gonna stop this and double check my code, make sure we're all good. Okay, let's click run and see if we have any errors here. Okay, I didn't see any errors. Let's go in. Oh, we're still running. This might take a minute. This is a little bigger raster than we've usually used. So I'm just gonna, oh, okay. Let's see if that worked out okay. I should be able to go to my browser, my Landsat Data. I should have an NDVI when that finishes running. It may have crashed. Let me just see what I can find out here. Okay, and so we have an error here. I'm in line 40 with this isNA. So this should be np.isNA. We need to call numpy there. Let's see if that gives us a better answer. I'm going to run that. And I'm going to stop this. Hope we have another error. There is no module. No, actually isNA. Let me double check on that. I think I've done something wrong there. Okay, and that should be isNAN, not isNA. Sorry, getting my R and my Python mixed up here. Now let's click run again. Hopefully this time open another error. Okay, and so this is up here in our, when we do our create raster from template. E-type should have a capital T. Okay, let's go ahead and click run again. Sorry for all these errors, guys. And another error. Okay, and this one, same function, this line here. Get geotransform, the T in geotransform should also be capitalized. So let's go ahead and click run. Okay. Okay, and so we have the same kind of deal here. This needs to have parentheses on the end of get geotransform and on the end of get projection. And now let's click run again. Sorry guys, lots of errors in here. But this also hopefully gives you some practice debugging the code and seeing what it looks like. So that went away. I'm not sure why. Let's see. Oh, there's our ndvi.tiff got added, so it looks like things may have worked out. I'm going to close this, and we'll add that back in. Go to our layers. Okay, there's our NDVI. So NDVI values should range from 0 to or -1 to +1, and we can see those that we have that here. I am going to adjust the symbology here so we can see things a little better. Let's do a single band pseudo color, and sure, we can do red to green. We'll make this one, let's make this right at 0. And let's make that at -0.5, so we're kind of symmetric here. We'll make that at +0.5. Click OK. Alright, and there's our NDVI image. Sorry I moved it. We're being a little slow with the rendering here. So you can see if I zoom in that almost all of this has a positive value, not a lot of negative values. Let's actually go in and change the symbology again just so we can see the differences in it. And let's look at all our color ramps and see if we have something that let's try something like this, but we'll invert it. So to invert the color ramp, you right click, click invert, so our low values are in yellow. And let's just classify this again like that, and we'll just click OK on that. So now you can see again we have some lower values down in this area, higher values all the way around, lower values over here. These could be okay. So you can see these white values that got excluded. Those are probably some clouds maybe. Not a lot of low NDVI values here. That's okay. You can see this river kind of pops out when we zoom in on that. It has lower values. Anyway, there you have it. We calculated NDVI. We wrote some functions so that you can reproduce this hopefully quite easily. Once again, guys, I'm really sorry for the length of time this has taken, but this is how it goes a lot of the time when you're programming. You run into errors, you run into problems, but now that we've written that code, it's going to be super easy to replicate this and to batch process this if we need to. So thank you for watching. I hope that you enjoyed this video. And if you have any suggestions for future videos, please let me know. Don't forget to check out our Facebook page, Open Source Options, our Instagram page, Open Source Options, and you can check out the Community tab on the YouTube channel for some more information and additional posts. So thanks for watching, thanks for your support, and have a great day.